we've had a request to do winter 21. I believe it's here. Part 2. This is winter 21. T1. Part 2. It's the draw the Lewis structure for a long molecule. And yours will be about this size. It may be a little bigger, but not much. And we'll start from some piece that we recognize here. I recognize on the far left a pattern, a pattern that reads CHO, which we draw as an aldehyde. And an aldehyde is a carbonyl. Carbonyl. And the H is on the left because this aldehyde's on the left side of the molecule. And then it goes to a C with one bond to H. When we have a parenthesis in the middle of a chain of things, it means whatever's in the parenthesis is attached to the previous atom. It can't be the H. H is going to be sticking off the C like I drew, but the previous atom in the chain is a carbon. So that's an O2C. That pattern, CO2 to another C, is an ester. So this is not an answer to a question yet. Ald and ester. And when the O is listed first, O2 this way, we put it there, and the carbonyls here. Don't forget your lone pairs. And there's an H on the C. And I know some of you are tempted to call that an aldehyde by mistake, because you see the carbonyl attached to H just like the green. That second O changes everything, changes the behavior of the functional group in chemistry. So it doesn't do any aldehyde stuff, it's an ester. So we're at the CH, and then the O, we got the group, back to the chain. C with one H. And it's got an N as well. I'm going to put the N down here because I don't have room up there very well. NH with a C with 3 H's on it. A methyl on a nitrogen, really. Don't forget, nitrogen's nature, 3 bonds, 1 lone pair. Back to the chain. Goes to a C with no H's. We are currently here. No H's. Goes to a C with no H's. Goes to a C with 1 H. Goes to a C that has 2 of these OCH3s. What does that mean? Goes to a C that's got an O bonded to a C with 3 H's. Remember, show every bond. That's one of the OCH3s. The other is attached to the same carbon. That's what parentheses mean. Duplicates. Don't attach them to each other. And now it's time to fill carbon octets with pi bonds. Never fill carbon octets with lone pairs. It's not how carbon behaves. So pi bonds. Don't put a pi bond here. I'm going to erase this in like 2 seconds. What's wrong with that pi bond? It created an octet violation to the left. No, you need a pi bond this direction. And you're still not done with either one of those carbons. They're now surrounded by 6 electrons each. You need a second pi bond. And I think both carbons are fixed. Next carbon. Uh-oh. Don't put a pi. Oh, don't do this. Whoa, octet violation to the left. It's got to be to the right. And I think that finishes everything, doesn't it? Yeah, full octet, full octet. Good stuff. So 2B's done. It says 4 points. I can guarantee it's going to be 5. These are not major changes. I don't think there's going to be a rebellion for me doing this. That was a lot of work for 4. Okay. I want you to know that this is really important. So it's got a lot of points. All right. And then the next parts are indicate bond types for each bond. Please don't redraw your molecule. That's a lot of drawing already. Don't ever redraw something. Okay. So I want to put labels on bonds and then tell the teacher what each label means. Want to go with numbers? Yeah, I never go with numbers. I'm going to go with numbers this time. I put a 1 for this bond here. Now tell me, is that a sigma or a pi? That's what you have to start with. A sigma. When there's only one bond, it's a sigma. And she said it's an s orbital being provided by the hydrogen. And the carbon provides what? Yes, 3 sigmas, no lone pairs, sp2. I think there's only 1 more of those, 2 more of those. There's the C here that's sp2 attached to this H. And there's the C here that's sp2 attached to an H. I don't think there's any more, do you? This one's not sp2, not sp3.
Yes.
And that's sp3.
No, SP3.
Yeah, so I think we'll do those next. 2. They can go high on the screen now, right? Find all of those for me. I think there's one there. There's one there. One there. There's a lot. Sure beats drawing sigma SSP3, whatever. It's more, I think it's more than 10 times, isn't it? Yeah. Okay, that's my personal preference to do the H's first. You don't have to do that. Then I finish it off just left to right. Make sure every bond has a label on it. And let's go 3 here. It's the first bond. So what kind of bond is it? Yeah. And the hybridization of the carbon is sp2. And the oxygen with 1 sigma bond and 2 lone pairs, sp2 as well. Okay. And I think I can do that for the other carbonyl. And I think I can do that for this alkene. Oh, I used a word you haven't heard before. The C double bond to C is sp2, sp2, isn't it? Don't do it here. No, those aren't sp2s. We'll go over to 3. That is, I did 3. That's not a 3. 4 sigma sp2 on the left. What is it on the right? sp3. Let's see. I think I have another one right. Yes, it's different looking, but it's really sp2 on the left, sp3 on the right, sp2 on the top, sp3 on the bottom. I think I got all the 4s. No, there's one more right here. Look at that. sp2 on the right, sp3 on the left, sp2, sp3. Doesn't matter left and right. So I got all my 4s. I got to put 5 for the next one. We'll go up here. The carbon underneath, sp3.
SP2,
Oh, careful. 4 sigma bonds, sp3, that's the carbon. Oxygen, 2 sigma bonds, 2 lone pairs, also sp3. That's the oxygen right here. And then 5. We're not done with 5. That's a 5 there. That's a 5 there. That's a 5 there. That's a 5 here and here. And that's all of the 5s. 6. Just keep moving left to right till you got all the bonds labeled. 6. Sigma again, sp3 on the left and a carbon on the right that's got 2 sigmas and no lone pairs, sp. And I think that's the only one like that. Yeah. 7. sp on the left, sp on the right. And that's the only one like that. 8. sp on the left, sp2 on the right. And I think the sigmas are done. Every sigma bond has a label. After you finished your sigmas, time for dessert. Pies for dessert. I can tell you right off, I always make it so you're going to need 2 labels for pie every time. If you have just 1 pie label, then you're going to miss a half point at least. So give me the name of 2 different pi bonds. You like PY for the first? And what for the second one? I like that. Said like a Canadian. She said Zed. I haven't heard that in a little while. Well, actually, I visited Mom a couple weeks ago. It came up, the Z versus Z thing. Okay. PZ, PZ. First pi bond came up. I won't use green there. I'm sorry. I got green in my molecule. Here's baby blue. We'll just call this one 9. You want to call all of them 9 except for the ones where an atom has to do pi bond in different directions. So one of those is a 9. And then do we get all the pies except for the one? We got them all except the one. You can't call both the green one and the red one the same because you can only use an orbital once. So 10. And we are done with the labeling of bonds part. That's worth 6 points. That's big. The geometries are easy too. I try to get all 5 of our geometries in every example. I hope you notice that too. All 5 usually show up. So I'm going to use big capital letters. And I'll go with hot pink. A. Those are all sp2 carbons, aren't they? Let's see. I need to see my molecule. Don't need to see my face. And if you're keeping track, that was 3A. And now we're doing 3B. Yeah. And A, what's the name of the geometry? When you're sp2 and no lone pairs? Trigonal planar. Yeah. And I need your angle too. Yep, 120. Good job. We don't do labels of geometry for atoms on the outside because they're not central. So we move over to here. That's B. I think I have a few B's. every sp3 carbon, I guess it's more like a several B's. And what do we call the name of the geometry? Tetrahedral. And what's your angle? Let's see, am I gonna run out of room? C. I don't usually like the C, but it's in pink, so it's a different color. I think there's 3 big C's. All of the oxygens that are sp3. And what do you call their geometry? Bent. And when you're sp3, what's your angle always? 9.5. And a big D. Big D. D, 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 D. You want to go with these 2 sp hybridized carbons next? What do you call those? Linear. 180. And I think we only have the nitrogen left. Is that right? I think I missed one of my sp2 carbons. You see it? This one here. And that was trigonal planar. That was A, wasn't it? I missed an A. And then we're going to go E for nitrogen. And try to squeeze it in. Well, we don't have to. We see the nitrogen there. What do you call sp3 atom with 1 lone pair? Pyramidal. Pyramidal, and it's sp3, so your magic angle 9.5. And we're almost done. We have to do our functional groups. And we'll, I don't know. I think we'll just do it in baby blue. And that's an aldehyde as discussed earlier, right? And up here is an ester. You could say carboxylic ester, but you don't have to. You can say just ester. And there's a nitrogen, so you've got it narrowed down to an amine or an amide. Amine with the N. And you get half credit for amine. And she said secondary. I like her answer. She looked straight at the nitrogen and asked herself the question, how many bonds to carbon does that nitrogen have? She got the answer 2. She wrote secondary. And these are both the same. So if I go like this and this, they're both. How do I know they're ethers and not esters?
Because one oxygen.
Okay, I see where she's going. She said 1 oxygen. That's a good way to think about it. But neither one of these carbons is a carbonyl. One of the carbons in an ester has to be a carbonyl with a double bond to O. And as a consequence, when there's only 1 O, you can't have an ester. Yeah, you knew that. Okay. Very good. So there we go. We have finished this question. Give you a big look at it.
Mr.
Yes.
Can I put this and put the number before this?
We'll talk about that later, like in 10 seconds. I'm just going to close the video and then we'll talk about that.